Okay, hello out there in YouTube land. This is Noah Vaughter from DIYDSP.com. Today we're going to be working on this musical instrument. This is something I designed a number of years ago. It's called the Electric Eel. And if you've been following this series, the story is like this. I designed the thing, played it, used it in grad school, and then it got put into storage. And when I took it out of storage, it no longer worked. So I think we've had about 4 episodes so far where I've been restoring it. And I'm proud to say that we've worked through a number of issues, all completely live here. And in the most recent episode, I soldered together these keyboards here. I'll grab a few more so you can see these. The original Electric Eel keyboard was actually lost somewhere, and I spent a lot of time looking through all my stuff trying to find it with no luck. But in the last episode, you can go up online and look at it. I designed this circuit board and I ordered all these switches and put it together live. And in that episode, unfortunately, the battery actually ran out before I got to run the before I actually got to test the instrument. Actually, I tested the instrument here in the Framingham Makerspace, but when I looked back at the camera, I saw that the stream had stopped. So let's just do that. By the way, if you look at this nice electronics bench, I'm inside the Framingham Makerspace in Framingham, Massachusetts. We've been a makerspace for, 2, 3, 4 years now, and we recently expanded. We actually doubled in size to include a bunch of studio spaces. So I've got a studio space down here along with a bunch of other artists, designers and things. And this is our part of our new electronics bench. I was just, some people the other Saturday night, they came and relocated things to the other room, and then I set it up to look nice by putting the scope here and everything, and just, this is going to be the first project that's actually assembled here. So I'm pretty excited about that. So let's see if we got anybody logged in and watching yet. Oh yeah, we got somebody already. Hey, thanks for watching. Thanks for tuning in. So let's get started. One thing I want to do is just demonstrate how the instrument works and how the actual keyboard works. And make sure that that fits in the frame. Yeah, okay. It does. So this is a generator instrument. This is actually the electrical generator here. That's something I invented myself and worked out while I was at the Media Lab at MIT. And basically what happens is you rev this part here, and you see the light glowing? That's us generating electricity, and you hear the sound. And then all you have to do is hold down a keyboard button, and you've got a note. So there we go. So we proved that the keyboard works, and soon I'll be able to attach it here. But notice how this is only 4 keys. One thing that I probably just started to get into in the last episode was that this is a matrix keyboard. So it's actually designed to handle, I think, 4x4. And the original instrument actually had 8 keys on it. Each key gives you an octave, and so it could do 2 octaves. And this time I decided to upgrade it because in the time between when this guy went into storage, I've been playing my other Electric Eel a lot. You can go online and see my Christmas music videos that I like to make. And I found that every now and then I actually really need that 3rd octave. 2 covers most songs, but since we're touching this anyway, let's give it a modest upgrade. So how does that actually work? Well, in a matrix keyboard, you can basically take the number of wires that you have available and calculate how many keys you can use. So I have 8 wires allocated on the synthesizer board to make the keyboard. You could divide it up in various ways, but I chose, for simplicity's sake, to divide it up into a 4x4 matrix. So that lets me access 4 keys separately, and I can have 4 of these sections. Now, as I said, I'm only going to use 3 of them for 3 octaves. And that also means that, well, let's take a close look at how this works. If you can't tell, there's 5 wires there. There's 4, one for each button, so you could call those the column of the keyboard. And then there's the fifth one, this red one, and that could be called the row. So all four of these would be the same row, and then when I add a second one on, that's going to be a second row. And when I add the third, that's going to be the third row. But they all share the same columns. So the long story short, all three sections of the keyboard have to have these same four wires. Now I could get the soldering iron and just solder a whole bunch of wires, but I actually designed a facility into this thing to make it easier. Basically, all you have to do is solder to, see if I can focus on that. All you have to do is solder to there, and then you see these other 2x6 connectors? There we go. These are actually linked to these four of these wires here. So I could just have one set of 4 wires go in here and then make some little connector that goes from this one to this one and then onto the third one. Then I just have to attach the row wire separately. So it makes it a little easier. So that's what we're going to do today. Are you ready? Let's solder. So I'm going to rotate the camera. Don't get seasick. Over to the new soldering bench here at Framingham Makerspace with our generously donated soldering iron and everything. I'm going to move the camera in a little bit. Actually, while we're here, let's just peek around. You can see my studio spaces down there and Gase's. CNC equipment, more CNC equipment. There's the walls, more studio space, and through that wall is the is the rest of the makerspace with all our tools and workbenches and stuff. So let's focus in on where we're going to be working. Come this way a little. There we go. I'm going to untangle my microphone cable. All right, let's power up the old soldering iron. I like how neat and organized this is. You got your basic tools here. You got your solder wick. You got your alligator grabbers. You got the excellent screwdriver from DIY or You Do It Electronics Center. Love these things. So you got 2 different size Phillips and flatheads on both sides. Every time I go there, I pick up another one for $1.99. All right, let's see if we've got any kind of heat yet on the solder. Yeah, we're at 700 degrees. Beautiful. All right, now I want to show you a mistake that I actually made in the boards. It's not exactly fatal, but well, let me show you all the pieces. So I've already talked about these 2x3 headers that are going to be used to replicate the signal. This here is the actual ribbon cable that we're going to do. So let's cut off some pieces of that first. So it takes 6 wires. And I prefer to just stick with the color code of brown, red, orange, yellow, green, blue. I don't expect there to be any serious problems with this section of the circuit, but it always makes it easier to debug. I'm going to make 2 of these, make them the same size, just cutting those with the diagonal cutters. There we go. All right. Now these are what we call, make sure this comes in focus. This is what we call IDC, for insulation displacement connectors. So they got those little blades, little sharp blades there, and then they have 6 little holes in them. So the ribbon cable actually goes inside there, and then we're going to squeeze that down. All those blades are going to cut right through the plastic of the insulation, and then they're going to make electrical contact, and that's why it's called insulation displacement. And what do they connect? This stuff here, which is called, let's see, what actually makes that come into focus? I don't know. It just does it when it wants to. There we go. It's beautiful when it does. So this is dual row header material. So it comes in 2 rows like that, as you can see. And this actually mates with this part here. Okay. Now, of course, this is too big, so the nice thing about this is if we can get it to focus, yeah, it's actually pretty breakable. So I'm going to break this off into some 2x3 units, just like that. Okay, so just cut that off. All right, I'm going to make a couple more of those. I think I need 4 of these. So there's 2. I go to the 3rd one. All right, and here's the 4th one. Ah, someone else joined. Excellent. Thank you for joining us. I'll be checking the chat from time to time, so if anyone has any questions or whatever, go ahead and just jump on type of way, and we'll see you. When I see them, I'll respond. Okay, so here's the original part. I'm going to be attaching it over to this with the insulation displacement, or IDC headers. Now remember I said I made a mistake? I'll show you what the mistake is. I originally intended for you to put these 2x6 right there on one of them. Oh, that pin is bent, that's why. Let's unbend that, my fingernail. Not quite. Let me get the pliers. Oh yes, they're very conveniently located on the newly set up workbench. How convenient that is, just to have a nice flow. Okay, straighten some of these other pins a little bit. Okay, yeah, so I originally intended for you just to be able to stick these in here and then to put the header on like that. But as you can see, that's not going to fit. So we have a workaround. Just going to stick it onto the other side like this. So in the next rev, I'll be sure to make it a little bigger so you could just do it. But it's just going to work the same exact way like this. So let's put those 2 in there. And then this guy gets one on that side. Okay, and I have one more. Where'd that go? Here it is. So just place it just like that. Wonderful. The pins are sticking out, so I'll just solder those right in place. And let me just make sure I've imagined it right. Oh, actually, I got to put that one on the other side. Over here. Okay, so there's that one. And this pair here. And this one's a little loose. It's going to attach like that in this side. Okay, so that's the first part of the work that we have cut out for us. We're going to do that soldering, and then I'll show you how to do the insulation displacement connectors, and then we'll try and hook it up to the actual instrument. So first I'm going to try and zoom in a little bit more on the soldering area. So I'm going to lower the camera Don't get seasick. There we go. Coming a little closer. All right, that's that. I do that so you can tell what's going on. Slide over just a little bit more. Even get that backpack out of the way. All right, here we go. This is a pretty easy job as far as the soldering goes. Something like this, just want to tack a few pins in, make sure that they're in straight. So just go through and do all my tacking. So for the tacking, I just solder the first pin in. Just like that. Now let's just look at it visually. Yep, that's pretty straight. That one's, see, this one's off by a little bit. So the nice thing about when they're tacked in is you could still adjust it by like putting your thumb, kind of adjust it there and then heat the joint. See that? How about this one? Yeah, this one's fine. Okay. Let's do some more soldering. Can you see what I'm doing here? Yeah, okay. Oh, I made the joint kind of overlap there. Oh geez, all together. This tip's a little large. I'm kind of making a mess. All right. Well, it's a good thing I have my solder, what do you call this, solder ribbon or whatever here, just to pick up some of that excess solder. Kind of went a little too fast. What do you think? That's beautiful. Let's keep going. Two. Same thing happened again there. Okay, that one's done. So you can go back and learn more about the switches in the previous live episode. But basically, these are called Cherry MX switches. And there's an online community of keyboard devotees, mechanical keyboard devotees, and they love to make their own keyboards, you know, full computer keyboards for typing out of these kinds of switches. They usually like the loud clicky ones, but I like these because they're the quietest. I forget which color these are. I think it was the reds. So the different colors of the keyboard stems, the switch stems, tell you about their mechanical properties. Some are made to have a loud click, but these are the quietest and the fastest, because in the time I've been playing the other electric eels, I made some recordings and I found out that some of the switches are loud enough that when you play quietly, you actually hear the switch significantly loud. All right. So now this is roughly the way it's going to go. This one is going to have connector going over to this one, and then this one is going to have a connector going over to this one here, and we're going to have a, oh sorry, you couldn't see that. So this one connects to here, then this one connects to here, and I'll have a nice 3-octave sound. Now how do I do this? You know, one way to do it is to have just a whole bunch of wires soldered everywhere. The other way is to use these insulation displacement connectors that I was talking about. So let's line these all up. Oh, I got to get 2 more out of the bag, I guess. Let's get that stuff off, right? It's my little bag of parts. So these I just order from DigiKey. Probably a lot of places have these. But if you want, just, you can use this part number if you're ever connecting everything with 2x3 IDC headers. Oops. Okay, so now let's kind of figure out where this stuff's going to go. Important with these is to get make sure they're all facing in the right direction. I mean, you could do it without making them face all the right direction, but it's kind of a recipe for confusion. And I like to think that what I do is complex enough that I don't need any factors to complicate it. Oh, look at that, we got a third person. All right, welcome third person. Thanks for joining us today. If you don't know what's going on, I'm making this keyboard for a musical instrument I designed many years ago. And when I restored it from storage, I found it didn't have the keyboard anymore, so I had to newly create one. So stick around for a minute and you'll probably get to see us try this. So that's where those two go. Now these have to be pretty close together. The way the system is designed is that all the keys are going to be equidistant. So I cut these a little bit long. So typically what I do is I also put a loop in there, just so it can have some variable distance. We can put it in the loop after. But let's talk about how these actually attach to the IDC. So one thing I like to do is I look at the pin numbers. If you look very close, you'll see that's pin 1 there, and that's pin 6. So pin 1, remember it's in the bottom right there, so now it's that corner there. That's associated with the color brown. All right, remember BBROYGB? So again, you don't have to follow that convention, but it just makes it that much easier. So basically, let's try and do this up close on the camera. Let's see if it snaps into focus magically. Sometimes it does, and sometimes it doesn't. There we go, that's so beautiful. Okay. So what we do is we actually just slide this in, like that. How close can we get? Oh, look at that. And now I always leave a little bit of slack out there. You can always trim it. So this is a 2-step process. The first thing I do is I squeeze it down a little bit with my fingers. Make sure it's at a perfect 90-degree angle. Now I'm going to go and grab my vise. One of these things. Why? Because it could squeeze nice and hard and nice and even. So what I do is I loosen it up. Put it inside there. Just like that. Make sure the position is good, and then just tighten it like this. Now this actually has some bits on the side. See that little like lever thing there? That makes it so it's not going to simply separate again. All right, so that's actually on there pretty good. It's like one way. So I'm going to go and I'm going to get the other half of it. And I'm going by, see these little double tabs there? You can see it on one side, but not the other. I like them all to face the same way. And this is the same thing, goes right through like that. Hold it gently in place, and put it in the vise. Oh boy, you know, I just got a message that my battery's low, so I might take a moment here and plug the phone in so same thing doesn't happen last time, because I think you're going to want to see the conclusion of this. There we go, beautiful. All right, so here's my little power supply. Plug this in on the wall. There we go. All right. So what this means is we can plug this in to that keyboard here, and that extends over into this section. Just like that. And so now we've got one set of wires that's going to attach over to the microcontroller, to the rest of the instrument with this, and we could have both keyboards going. Of course, we are going to have to attach the row wire. That's not a big deal. And then notice how I said that these are supposed to be close together. You can either hold them like that, or I like to put a little curly cue in there, like this. Roller coaster. Maybe like this. There you go. That takes up some of the slack, and now they can be right next to each other. All right, so let's do the third one. So here's the third keyboard segment. We'll take his little IDC. Remember, we're putting the brown towards the back because that's associated with pin 1. Push it right through. Squeeze it finger tight. Bring in the vise. Put it in loosely. Squeeze. Now I take it out. That's connected for the long haul. Take the second half here. And again, keep the alignment the same when you do this. Makes everything easy. Squeeze it finger tight. Those little metal guys. Tighten up. All right. There you go. Oh, cool. We got a second thumbs up on the live stream. Nice. Thank you very much. Oh, yeah. I wasn't watching what I was doing, though. And this one's backwards. All right. Stop paying attention to that. So, unless anyone has any better ideas, this is kind of actually just that side is ruined, so it's okay. I got a whole bag of them. Just rip it apart, throw it away, start over again. That's so funny. I'm like too busy watching the number of likes. There we go, okay. Now, when that happens, notice how the, if we get some focus there, the insulation's got some damage to it. So what I do is actually just trim that right off, because I'm not sure it'll work twice. Very good. All right, and I'll get out a new header. This time I'll repeat 1,000 times to myself, I will match the orientation of my IDC headers. I will match the orientation of my IDC headers. There we go, just like that. All right. Now it's in place, and we squeeze. All right, this is going to be good. Let's try and stick around for the next few minutes, because we're almost ready to hook this up. Then you're going to hear some beautiful instrument sounds. All right, there we go. Done with the vise for now. Go to this keyboard segment. Attach the header just like that. Go to this next one. We'll put our curly Q in now. Ta-da! So now we have 3 and all of their columns are connected. All we have to do is just solder this one. Remember I said the row connector on this one is the red? I happen to have checked before. It's the brown for this one. And to be quite honest, because I have never used the 3rd octave before, there's no wire. I mean, the software isn't even going to read this other keyboard yet, so we're only doing 2 today. Maybe in the next episode I'll update that. So get the soldering iron. This is really easy when they have one connection to make. Okay. Just like that. Actually, I'm going to trim that because it's a little long. Just a little dab of solder. Sorry, I can't see that just right now. Okay, that's all that took. All right, are you ready to test this? Ready to hear the sound? I know I am. I haven't heard this instrument play with 2 octaves in so many years, probably since the last time. I don't know, the last big concert we did with this was probably over at SDSU, San Diego State University. Woo! Out in California with Dr. Joseph Waters and his many students. Let's see, that was Jaquil Garvey and Daniel was part of that troupe. Who else played with us? Anyway, those videos are online. You can go and you can find them. You can see us jamming out, playing live on stage, playing anywhere we could go because these instruments have generators, right? They don't need batteries. They don't need to plug into the wall. All right, it's a little bit of a delicate thing. See what I'm going to do. I'm going to unplug the electricity from the phone so I can slide you down this way. There we go. Oh yeah. No. Don't have a place to plug that in. This is only going to take a few more minutes. So let us hook up the keyboard to the microcontroller. All right, that's done. All right, now we'll bring the keys in there. Now I showed you the first octave working, so let's just test out the whole thing. All right, that's the first octave. Let's check out the second one. Yes, it actually worked on the first try. This is awesome. Woo! It's exactly what we wanted. All right. So, after all this time in storage, this instrument's starting to actually work. All right, this is pretty cool. Now, if you notice one thing, the pitches seem to kind of go backwards. This was the lowest one here. It went C, E, G, B, and then it started over here. So what's a way to fix that? I'll just swap this brown wire and this red one. No need to get complicated with it. And that pretty much concludes this episode. So, you know, if you like this kind of thing, I'm just going to keep working on this instrument, and I've been designing electronic music instruments for years and years and years and years. I'm going to keep doing this on this channel, so like and subscribe, ring the bell so you can get more of these live videos. Do all that stuff. Go to DIYDSP.com. I don't actually have any forums. You can go to the subreddit actually, reddit.com/r/DIYDSP, and you can see the work of instrument builders like myself and other people doing innovative stuff. And I just thank you for coming along on this ride. It's very interesting, very exciting. And go ahead and listen to my Christmas music performances, even though it's January. Still have the spirit. All right, this is Noah Vaughter, DIYDSP.com, signing off.